Pre-calc section 3.2 is on polynomial functions of a higher degree. Now what this section is trying to center on, it's on quick sketching of polynomial functions. Okay, in other words, quick graphing. Now we know we can always graph any function, and this stays true for any type of mathematics. If we plot enough points, connect them, we're going to find the correct graph. Okay, or at least something close enough we can figure out what's going on. What this section's for is for us to try and get quick sketches so that I know what's going on at certain parts of the graph. The first thing we run into is what's called the right-hand behavior test. Now your book actually talks about right and left hand, but we can do it with just a right-hand behavior test if we remember just a few different things. Okay, again, the right-hand behavior test is for the quick sketching of polynomial functions. So in general, if I have a polynomial function, okay, and it's no matter how big it is, whether it's the second, third, fourth, fifth, sixth, seventh, 10th power, doesn't matter, we can graph that function. The first thing we have to be able to do is find the roots. Okay, and we're going to go over a little more of that in sections after where we're at right now. But if we find the roots, we can figure out what's happening at both sides of the graph by what's happening or what the information is given to us. In the first one says if a is greater than 0. In other words, if this coefficient here is positive, okay, if it's positive, and n is even, okay, and that exponent is even. So all I'm doing is looking at the first term. None of these over here really matter as to what's happening at the ends. So if a is positive, now the value of a is going to tell me whether or not the right side goes up or down. Okay? So if a is positive, the right side is going to go up. Okay, and all of these again have to do with the right side. If n is even, both sides are going to do the same. Okay? So if a is positive, the right side is going to go up. But if n is odd, the two sides are going to do the opposite. So positive means up, even is the same, opposite or bottom, odd is opposite. I'm stuttering here. So this is just a general look at the graph. We don't know what's happening between here and here. But I know from the rightmost 0 of that function, if a is positive, it's going to go up. And if n is even, the left side is going to do the same thing. In here, any kind of weird things can happen. Down here, if a is positive, it's going to go up. Okay, so a is positive, the right side is going to go up. But if n is odd, the left side's going to go the opposite direction. It's going to go down. And again, any kind of weird things can happen here. Okay, we'll figure that stuff out later. Now, what happens if a is negative? Okay, if a is less than 0, which means it's negative. Well, if positive is up on the y-axis, negative means it's going to go down. And the even means the same, and the opposite means, or the odd means the opposite. So, if a is less than 0, the right side is going to go down. If n is even, the left side is going to go down too. And in here, we'll figure that out later. If a is less than 0, the right side is going to go down. If n is, and I should have this saying odd, so it's not exactly the same as that. If n is odd, that one's going to go up. And in here, again, we'll figure it out later. So, all this does is help us look at the extremes of what's happening with that graph. What's happening as x goes to positive infinity, what happens as x goes to negative infinity. Okay, that's what the right and left-hand behavior tests are for. In the middle, we'll start looking at what happens at different x-intercepts, okay, or different zeros of the function. Now, we do have maximum and minimum values and turning points. If I look at these graphs, we will have maximum and minimum values between the extremes. We might have a couple of different maximums. We might have, depending on where I start and where I finish, we might have a minimum value. So any polynomial of degree n can have at most x-intercepts, or n x-intercepts. So I have the same number of x-intercepts as the degree. Okay, at most. I may not have as many, but I can have at least that many. And n minus 1 turning points. A turning point is just where I turn around, where I go from going increasing to decreasing, going up to coming back down. That's a turning point. Okay? So, if x to the fourth, and it just keeps going as bx cubed, so if I have something with x to the fourth, it can have at most 4 x-intercepts. At most. And 3 turning points. So an x to the fourth equation will have at most, okay, so here's my x-intercepts. Just draw a general graph. How many turning points do I have? 1, 2, 3. So n minus 1 turning points. Now the intermediate value theorem is not something we're going to use real heavily, but we want you to be aware of it. It just states that if p is a polynomial, okay, and p of a isn't equal to p of b, in other words, I don't get the same value when I plug him in. If a is less than b, then p takes on every value between a and b in that interval. All it means is this. If I have a polynomial, and again, a polynomial has certain factors to it. It's not divided by a variable. It's just something, a large, it's like a binomial, just bigger. That was kind of a dumb statement. Okay, a polynomial, just everything has to be up on the top. Okay, so like 5x to the fourth plus 3x cubed minus 2x plus 1. That's a polynomial. As soon as I put something down here that's a variable, it's not anymore. Okay? So, if I have a polynomial and I have an a and a b, I know that everything in here has to exist, every number. And what we can do then is we can use that to find out that there has to be, if one is less than 0 and one's bigger than, okay, above the x-axis and below, we know that it has to cross the x-axis at some point. Otherwise, it can't get from there to there. Okay? So here we go. A couple of examples for you guys. They want us to give the relative maximum and minimum of this function. Okay, this is on number 18 on section 3.2. Just turn the page over here to get to it. I'll read the whole directions. It says, use a graphing utility to graph each polynomial. Use the maximum minimum feature of the graphing utility to estimate to the nearest tenth. Okay, so we're actually using a graphing utility for these. So I'm going to show you how that goes again. Try and get out of that light. There we go. So turn your y equals on. Now we just got done with plotting in the last section. I turn that plot off, so I go up to it, hit enter, so it's not highlighted. Now we can graph. Negative 2x cubed minus 3x squared plus 12x plus 1. Okay, so there's my graph. Now my window is probably still off because I just got done making the video for the last section. So I'm going to go to my window. And I don't know exactly where this is going to be. Okay, so I'm going to just start with a standard window. I'm going to go negative 20 to 20. And I'm going to scale it by 2, which is the difference between. As we go on in this class, we'll have to learn how to set windows a little better. And I'm going to graph it. We should hopefully find our x-intercepts in there. There we go. So it's a cubic function, which means I can have at most 3 x-intercepts. And I show all 3 of them right there. Now, just to get closer to that, I'm going to close that x value in. I'm going to go to my window here. I'm going to change it from negative 10 to 10, just to make it a little easier to see. There we go. Now, we want to get relative maxes and mins. This has to be a relative maximum. It's the highest point between this minimum, or between these 2 x-intercepts. Okay? This is a relative minimum. It's the lowest point between these 2 x-intercepts. So, to find them, here's the fun part. Now, what the book has you do is has you trace it. But you'll only get really close with the trace. So let's use the power of the calculator. If I want to find a relative max or min, follow my keystrokes. Over here, under the trace, I've got to calculate. Hopefully you can see that. So I'm going to hit second calculate. Now I'm trying to find a max or a min. I'm going to try and find the maximum first. Okay. Now, see this, the flashing cursor? I have to be on the left side of that highest point, just somewhere on the left. Okay, hit enter. Now trace it over. Make sure you're on the equation. I have to be somewhere on the right. So now what it's going to do, it's going to find between the first point I hit and the second, it's going to find the highest number. There's my right point. Have it guess. So a relative maximum here is at 1. So I've got a max at x equals 1, and the max is 8. Okay, I'm going to do the same for a minimum. Second calculate, I'm going to go to the minimum value. Now again, I go left to right. So left bound, I got to get to the left side of that. Hit enter. Right bound, I'm going to trace it over to the right side of that. Hit enter and have it guess. So the relative minimum is equal to negative 19, and it happens that x equals, now it says negative 1.99999. I'm guessing that's going to be negative 2. If we plug negative 2 into this equation, negative 2 cubed is what? That's going to be 16 minus 12 minus 24 plus 1, 36, 20, yep. So that actually is at negative 2. Now, sometimes your calculator won't give you the exact value. You just have to think about it a little bit so you can get the correct one. Okay, so we have a relative max and a relative min. How you find it with the calculator. Number 24 wants us to find the real zeros of each polynomial function by factoring. Okay, so it wants us to factor it, find the actual zeros. Okay. Now, how many zeros are there? Well, there's up to 4. Now that's real and complex. So I'm going to try and factor this. Now it is quadratic form. So 4 times 9 is 36. Factors the negative 37, which is negative 36 and negative 1. So 4x to the 4th minus 36x squared minus x squared plus 9. Factor out of 4x squared, which gives me x squared minus 9. Factor out a negative 1. Factor out the x squared minus 9. Now set each of those equal to 0. Plus or minus 3. 4x squared equals 1, so x squared is 1/4. So x equals plus or minus 1/2. We have the 4 zeros, the 4 real zeros from there. Okay, and that's all they really wanted us to do there, just be able to find the real zeros. Number 46, let me turn the page here, says sketch the graph of the polynomial function. They don't want us to use the graphing utility. So to sketch the graph of a polynomial function, the first thing we need to do is find the zeros. And then we can use the right-hand behavior test to graph the rest. Okay? So I'm going to find the zeros. Here I'm going to factor an x out first. This one then I'll factor into x plus 3, x minus 1. So my zeros are 0, negative 3, and 1. Now if I'm going to draw just a general graph of this, I find my zeros, 0, negative 3, and positive 1. Okay? Let's look at the right-hand behavior test. A is positive. That tells me from this side it goes up. Okay? This is odd. Tells me on the left side it goes down. Now, all I'm looking for is any double roots or even roots. Things to remember that I haven't mentioned yet. Even roots, I say it like that, it doesn't work out right. Multiple roots, or the multiplicity that they talk about, that are even, of even power, reflect. I'm going to show you an example of that here in a second. But all of these are just single roots. None of them are double roots, okay, where they happen twice. So all of these go through. They happen an odd number of times. So a general graph looks like this. Now your actual graph could be, something a little more like that. We actually don't know unless we plot more points in the middle, okay, of how it's skewed. But if I had something like this, okay, when I solve this, I get x is 0, x equals 1, which is a double root, negative 3, which is a double root, and 5. If I graph that, okay, I've got 0, 1, 5, and negative 3. Right-hand behavior, they're all positive, so it's going to go up over here. Now, I just look at how many times this root appears. If it only happens once, I go through and back to the x-axis. If it happens an even number of times, and that's when I say the multiple roots of even power, this one happens twice. If it happens twice, it reflects off that axis and goes back. This only happens once, so it's going to go through and come back. This one happens twice, so it's going to reflect. Okay, so that's how we can graph with looking at the x-intercepts and how many times they happen. Now, if it happens to be a triple root, it's still going to go through. So I could change this 5 to a triple root, have 2 more x minus 5s here, and the general graph would still look the same. Okay, that can help you with finding a little bit of domain and range too. So hopefully that makes sense to you. We're finding the relative max and min with a calculator, being able to find the zeros and our general graphs.